In a world with one camera and no cord, 4 kids set out on a mission. With only $42.34, a physics project was born.
Projectile motion refers to the motion of an object projected into an air at an angle. A few examples of this include a soccer ball being kicked, a baseball being thrown, or an athlete long jumping. Even fireworks and water fountains are examples of projectile motion. In this lesson, you will learn the fundamentals of projectile motion. You will be given examples and interesting facts.
Projectile motion is one of the traditional branches of classical mechanics with applications to ballistics. A projectile is any body that is given an initial velocity and follows a path determined by the effect of the gravitational acceleration and by air resistance. For example, a thrown football, an object dropped from an airplane, or a bullet shot from a gun are all examples of projectiles. Projectile motion may be used to solve mechanical problems if the acceleration is constant. The path followed by a projectile is called a trajectory, and it's affected by gravity.
Projectiles actually follow a curved path, yet no one knew what that path was until Galileo. He reasoned that a projectile is not only influenced by one motion, but by two. The motion that acts vertically is the force of gravity, and this pulls an object towards the Earth at 9.8 meters per second.
The change in the vertical direction equals the initial velocity times time plus 1/2 acceleration times time squared.
The projectile is also moving forward, horizontally at the same time, and this horizontal motion is uniform and constant according to Galileo's principle of inertia.
The change in distance in the x direction equals velocity naught times time plus 1/2 acceleration times time squared.
A projectile is controlled by two independent motions, and these work together to create a precise mathematical curve. He usually found that the curve has an exact mathematical shape, a shape that the Greeks had already studied and called the parabola. The conclusion that Galileo reached was that the path of any projectile is a parabola.
To demonstrate the principles that we just discussed, we are having Paul fire 15 rounds out of a gun that is going to show the change in the height of the bullet, which is the y direction, in comparison to the change in the bullet's distance, which is the x direction.
Go ahead.
By using a ballistics trajectory calculator, we were able to find the trajectory path of the bullet.
We input the distance and the air temperature. The other variables to the equation were on record listed with the type of bullet and gun used.
The path the bullet took could therefore be determined. This graph depicts the amount the bullet will fall in the y direction. As you can see, the graph is a parabola.
Look at the graph, you'll notice that on the x-axis it shows the change in distance of the bullet from 0 to 100 yards, and on the y-axis it is showing you the change in height of the bullet. Now that's recorded in how many inches the bullet is dropping. And this concludes our presentation on projectile motion. Hope you learned something.
I'm good. Now, what am I supposed to be doing? You or the
red button? Just get try to get everything.
He wants you like here.
Just get like an angle.
Like
Good?
here. Deb.
All right, Russell, stop screaming.
No, I'm just saying back here so he gets the target.
All right, I got it. Go ahead, Paul.
So you have to hit go
You have
when
to
you're ready.
unlock this gun or anything?
I'm on
red.
record.
You hit red when you're ready.
It is
Dad,
record.
you have to unlock the gun.
Fuck,
You have to unlock the gun.
Shut it off.
Alright, go see Cassie. Yay, we're all in the video now.
We're done.
Alright, let's go. I'll get it.